Hey, what's up everyone? Jason Turley here, back with another video. Today we're once again looking at the DAM vulnerable web application. If you're unfamiliar with what this is or how to set it up on your own computer, be sure to check out my part 0 video that I made a couple weeks ago. You can see on the left-hand side, it's a list of very common web vulnerabilities. We already took a look at the command injection one a couple weeks ago. Today we're going to look at the file inclusion one. So clicking there, we see vulnerability, file inclusion, and there's 3 files here, file 1, 2, and 3, and they all are .php, which is just a common backend programming language for web servers. So that's cool. We can click on file 1, and it pops up here, hello admin, that's the user I'm logged in as, and your IP address is 127.0.0.1, so localhost. We can see that here in the URL, so that's not surprising at all or concerning. File 2. I needed a password 8 characters long, so I picked Snow White in the 7 Dwarves. So that's a, dad joke, right? I need 8 characters, and they're talking about password complexity, and then this person's talking about, 8 people, 8 characters in a show. File 3. All right, welcome back, admin. Your IP address is this. Your user agent string is this, which is just a way to identify what kind of computer you're coming from. I'm on Kali Linux, so it's showing here that I'm on a Linux system. Cool, nothing concerning. And it tells me what IP address I just came from, what URL I just came from rather, and then the host. All right, we have more information down here on what file inclusion is. You can read up on that if you want. But if we scroll down, we see 2 buttons here, one to view the source code and one to view help. I'm currently on the lowest level difficulty or security setting. There's 4 different ones, low, medium, high, and then impossible. We're going to solve all of them in order. So let's go back here and scroll down to view help. Make this nice and big for you guys to see. All right, cool. So what are we supposed to do here? File inclusion. Some web apps allow the users to specify input that is used directly into file streams or allows the user to upload files to the server. At a later time, the web app accesses the user supplied input in the web application context. By doing this, the web app is allowing the potential for malicious file execution. If the file chosen to be included is local on the machine, it's called a local file inclusion, but files may also be included in other machines, and this is called remote file inclusion. So essentially all this is saying is if we come back here and scroll up a bit, you can see my URL. There's this parameter. So anything after a question mark is a parameter, right? It's some type of variable. So the variable is include.php. That's the current page that I'm on that shows this. If I click here on file 1, we see that parameter right there, that variable, it changed to the name of the file that I wanted to access. So this is local file inclusion, right? This file is stored locally on this server, and it's included in this parameter, right? So where is the vulnerability in this? How can this be exploited? Who cares? That file inclusion is there. So we see file 1, 2, and 3, and in the bottom left-hand corner down here, as I scroll over it, you can see what the new URL will be. So I can change file 3. I can just poke around. There's a file 4 exist. File 4 hidden. Good job. This file isn't listed at all on DAM vulnerable web app. If you're reading this, you did something right. Winky face. So it's saying this is like a quick little example of how to access other files on this system. Besides the ones that the programmer or the developer or the system admin wants you to access, you can access things outside of the regular location. We can peek at this help menu once again, and it gives us an objective, a mission statement, right? Read all 5 famous quotes from this URL. The 2 dots and then the slash mean move up 1 folder location, move up 1 directory. So we can grab this, I guess just right click and copy. And let's see, instead of file 4, let's slam that in. Oop, that's not what I wanted. I want to copy this. All right, let's include that as our page. And we get nothing. We get a blank response. Everything else loads, but not the actual file, right? Add 1 more // to go up another directory. And there we go, right? So 1, Bond, James Bond, My name is Sherlock Holmes. It's my business to know what other people don't know. Line hidden, another winky face. Whoever created this really likes winking at us. The pool on the roof must have a leak. All right, so why did we need to add that extra dot dot slash? If I come here, so by default on Linux-based systems, the location for web servers are var www html, and inside there I have this directory called DVWA. I went over this in the setup video, so if this doesn't make any sense, you can go there. So I'm in DVWA, and here's that directory that we were looking at, hackable flags. And then right there, fi.php, I can cat that out. And it gives us exactly what we saw before. And then some other like source code stuff. The reason I needed 2 slashes, right? So I need to go to vulnerabilities, list all the different vulnerabilities that you see on the left-hand side, FI. And then here's the 3 files, the 4th hidden one, include.php and index.php. So I'm in this directory. I need to move up 1, 2, and that puts me here. And then I just go to hackable, and then the flag thing that we saw. So that explains that. So that's a relative path. If I want to provide the absolute path, I can. var www html dvwa. Again, hackable. Is it just flag? I already forgot. Hackable flags fi.php. It did not like that. Okay, there we go. So this is an absolute path, right? The correct file location, or you can use relative, which just means adding dots. It's relative to whatever folder you're currently in. Not every server is going to have some type of flag. So usually a proof of concept for a penetration test or any type of engagement is just being able to read etc password, right? That's readable by everyone. This is pretty ugly, so I hit Control U on my keyboard. You can also just do right click, inspect the source code. And that's going to make it a little prettier, a little easier to read. And you can look at all the users I have on the system. Of course, I have the root user and their default shell is G shell. And then there's also the Kali Linux user and then anything else I added. So that's the local file inclusion vulnerability for low security. It's kind of a low threat level, right? Nothing too serious happened, but if we were able to read config files or SSH keys or API access keys, source code, config, stuff like that, it can be more dangerous and more harmful to the company. So now, how can we exploit remote file inclusion? Start by creating a very simple PHP web shell, because we know PHP is installed on the system. I'm just going to name mine backup.php. I don't like naming it stuff like shell.php. I think that's too obvious. So I have my PHP opening and closing tags, and then simply run the system command. So we're going to provide our own parameter, right? We saw here that the parameter is page equals whatever. We're going to make our own called command equals whatever. So save and exit this, WQ. We also need to start a simple Python web server. Just like that, listening on all interfaces. I probably could have locked this down to just localhost to make it a little bit more secure so no one else can access it on this port. Coming back here, let's clean this up. So now, instead of having page equals etc password or file1, I can simply have page equals the URL. So http localhost 8000 and backup.php. And now I need to provide my own parameter. You can provide parameters with a question mark, but since the question mark is already used, we need to use the ampersand, cmd equals, and then whatever command. I know this is a Linux system, so I'm going to use ID, hit enter, and then it prints out what user I currently am, www.data. We can do other stuff. We can do current working directory, see what directory we're in. We can do an ls, tag la, just enumerate the system a little bit, see what's on here. Cool, that looks super ugly, hit Control U, and now you have a better, cleaner layout of what's going on. So you have remote code execution. You have a web shell named backup.php. You can use this to gain some type of reverse shell, so you have a better user experience, right? And you're not just entering commands through a URL in a browser. So that's how you do it for the low vulnerability. If we want, we can click here, view source, and here we go, low.php. All right, a nice little comment, the page we wish to display. Whatever we supply as that page input value, just print that to the screen. Nice and easy. So with that out the way, we can go here and change this to medium, right? A little bit more difficult, and go back to file inclusion. And we can still click here, we can poke around, and let's see if our previous two tricks worked. Can we access Etsy password? Yeah, we can. Can we access the flags? No, that doesn't work. What if I provide the absolute path? Var dub right there. All right, that works. The absolute path works, but the relative path does not. I wonder why. All right, it doesn't work for Etsy password either. Can I use my HTTP? That same shell? Hit enter? No. We see I'm getting connections from beforehand. So why doesn't this work? We can scroll down and we can pick at the source code for the medium level, and we see that it's changed, right? All this is the same. It's still including our input in the page variable, and it saves that as a variable called, or the page parameter, and that's saved in something, geez. So this is still the same as before. We create a variable named file. The $ file just means this is my variable, and give it the value of the page parameter. So file1.php, Etsy password, whatever, that's stored here. And now we do input validation. This was missing beforehand. This is a good secure coding practice. You don't want to just blindly trust whatever someone puts into your form or your website, your database. You want to sanitize it. You want to check it. You want to make sure it does not contain any malicious code. And ours did. So the two filters they have here filter out HTTP, which kills our chance of getting a reverse shell connection because we're over here. We're trying to reach out to our own server. It's a little bit confusing because both are on localhost, but this could be your own IP address or your own website. It wouldn't be localhost. So that does not work. So it filters this out. If it sees it, it's just going to replace it with a blank. So our command, we enter this, but what's really being executed is that. When you hit enter, of course, this doesn't work. It doesn't know how to interpret this, doesn't know how to use it. So if it's filtering out HTTP and HTTPS, and it's also filtering out our // right? That's why the relative local file inclusion path didn't work, but the absolute one did. So how can we get around this? Let's start with the remote code one first. So it doesn't like lowercase HTTP or HTTPS. But what happens if I make this uppercase like this and hit enter? Okay, it didn't like that. What happens if I intermingle upper and lowercase? Hit enter. Oh, I see. So I was playing around with this earlier and I named it update.php, but that's not what we want. We want backup. So this is the wrong path or the wrong file. Okay. Make it lowercase, it doesn't work. Make it uppercase or just change the capitalization at all. Enter. Now it works. Okay, that was an error on my part. So our web shell bypasses this because we changed the capitalization. It can be very simple. Okay, I think I beat that point to death. So how do we get around these .. slashes, right? It filters these out. It gets rid of them. Let me open up this. Hopefully this is good enough. So it replaces this with an empty character. So it just deletes it. But what happens if I do 4 dots and 2 slashes, right? It's still going to delete a .. and a slash, right? So dot dot slash, it's going to delete it, and it's just going to leave it with this because it only replaces it once. It's not recursive, it's not cyclical, it doesn't replace all occurrences, it will just replace the first occurrence it sees. So come back here, make it 4 dots with 2 slashes, make it 4 dots with 2 slashes, dot dot that, hit enter, and now we get it because it filters them out and it just returns what it should be, right? Dot dot slash dot dot slash. So that's how you bypass the medium security difficulty. Let's change this over to high, submit, go back to file inclusion. Cool. Just play around. Okay, everything works fine. Can I do Etsy password? Error, file not found. Okay. Before we weren't getting any type of error message, any type of redirection, but now we are. So that's cool. What happens if I try to do, I don't know, just add some dot dot slashes? You can see I did this earlier in my command history. That still doesn't work. Can I access my web shell? No, it doesn't like that either. Okay, let's get out of this. Let's go back. Let's look at the source code for this. And the reason I'm comfortable looking at the source code for these things is because this is a learning environment. This isn't a real penetration test or anything like this where we don't have access to the source code. So if you do have access to the source code and it is a learning exercise, I don't think there's any shame in looking at it or peeking at it or trying to figure out what's going on underneath the hood on the web server. So we see here the page we wish to display. That hasn't changed at all. We saw the page parameter is saved to a variable called file. And the input validation is changed. We don't see any hard-coded HTTPS or dot dot slash. All that is gone. This time, there's something called FN match. What is that? FN match with 2 parameters, file star, and then the variable over here. So what is FN match? Let's open up Firefox. FN match PHP. Let's click on the first result, the PHP manual. It doesn't get any more, I guess, authentic or official than the PHP documentation. So FN match file name against a pattern. Okay. We see the description. So it takes 3 parameters. Well, 2 parameters, a pattern, a file name, and optionally this flags argument. I can tell it's optional because it's already set to 0, right? That's something that these interpreted languages like PHP and Python, maybe even C, some programming languages support optional parameters. Okay, so there's a pattern and a file name. Check if the passed file name would match the given shell wildcard pattern. And then it explains these parameters in more detail. Okay, the return value, a little example. Checking a color name against a shell wildcard. So, okay, this makes sure the color is some spelling of gray. It has to be spelled Grae or Grey. All right, that's a silly little example. But essentially what it's saying is whatever file we pass in that page parameter, it needs to start with exactly FILE and then star, with the star meaning anything else. So if I minimize this window, the reason these work is because these are called file 1, 2, and 3 PHP. So that fits that regular expression, that fits that requirement. They all start with file and then whatever else. So how can we bypass this for local file inclusion to read Etsy password or read any other file? So if you're a bit tech savvy and you've played around and you've used computers before, you might know that you can open up files in your own web browser by doing file / and then the location of whatever file you want to access. So if I want to access, that's all caps. So home, Kali, can't spell. Let's just read my bash RC file, my bash runtime config. All right, that's not how you spell that. Is it just bash RC? There we go. My bash runtime config. So this is locally on my Kali box, right? If I open this up here, ls-la, just script for bash. So, right, I have my .bash RC file. That's not what I want. Okay. So I opened it up here in the web browser using this file : / URL syntax. So I can do the same thing here. So file / and then just etc password. And that's how you get that. It looks like all the other filtering is gone. So we can still do the / hackable. Maybe it doesn't work with relative location. I think you still need the full one. Okay, that's auto completed here for me. So that's how you get past that file inclusion boundary, I guess that filter, right? Not sure we can use this for remote file inclusion, because even if we use something called PHP web filters, right? Let's just look that up, PHP filter, remote file inclusion. All right, cool. One of the first results that pop up is hack tricks right here, books.hacktricks.xyz. It's a great resource. It's a great, I guess, cheat sheet study guide for all these different pen testing and security tactics, techniques, and procedures. So you can use something called PHP filters. All right, there's a lot of pop-ups. It's kind of ugly. Over here, click on filter bypass tricks. So this is what we did here. We did HTTP. Hopefully you guys can see that. And then RURL. And then whatever payload we had, they just called this mal.php. Ours was backup.php or update.php. But you can use filters, right? You can do :php and then add different filters, basically for encode different data or to include other files. But, right, the filter checks for file. It doesn't check for starting with PHP. So I don't think we can do any type of remote code execution on the hard difficulty, on the hard level. And then we can scroll down, look at view source, compare all levels, and we can look at these side by side, and then we can look at the impossible one, right? So this is the same as always, and only include that PHP or file 123 PHP. So they've changed it and they've hard coded it, right? They have to make sure, hey, if the file does not equal include.php or any of these files, print out the error message and exit. So there is no way to bypass this. This isn't the best solution in the world, right? Because there's only 4 files that they want us to access, so they can hard code it. That's not too bad. But what if there was like a million different files that we could potentially access? Are you going to hard code like 1,000 or a million, however much files into like this one if statement? That's pretty ugly and that doesn't scale well. And what if you rename a file and you had to change the code again? So this isn't the best solution, but for this little CTF, this little exercise, it's perfectly fine. Ideally, you would just want stronger input validation with FN match or PREG match, I think is the other PHP code thing. Quick Google search. Yeah, so perform irregular expression match. A regular expression is just a pattern. So you want some type of stronger pattern checking, but that's how we did it. That's how we solved it. That's how we got remote code execution for the low and the medium difficulties. We're not able to get remote code execution on the hard one, but we can get the local file inclusion on all 3 of the difficulties. And then the impossible one, hey, we're out of luck there. So that's really it for this video. I'm going to try to be more consistent and knock out some of these other ones because web security is pretty fun. It is pretty emerging, especially if you're trying to be a penetration tester. So that's it. That does it for today's video. Like, comment, and subscribe. Let me know in the comment section how you guys solve this. If there's any other tips or tricks that I missed out on. I have a Patreon. Follow me there. Support, subscribe. And as always, take it easy and see you guys in the next video.